Mr. Krishna Majumdar sir is there with us. I request our HOD to welcome Mr. Krishna sir. It's my honor to introduce Mr. Krishna Majumdar, a program manager at Bosch Global Software Technologies, Bangalore. A program manager at Bosch Global Software Technology, he leads the vehicle motion business segment with project and program management for customers, development of customer ECU projects, engineering services, and ECU engineering tools development with a focus on delivering high quality and customer-centric products. He has over 16 years of experience in engineering and project management, working with diverse and multicultural teams across the globe. He is passionate about innovation, strategy, and business development, and also he has been recognized for his strategic and innovative thinking during new business acquisition. He is also having strong background in people management, coaching, and mentoring. He has earned certification in people management and PMQ from Great Place to Work US and Robert Bosch Engineering and Business Solution Private Limited respectively. His mission is to leverage his skills and expertise to create value for his organization and his customers. Okay. Over to you, sir.
So good morning, everyone. You can hear me?
Yes, sir.
Last one?
Yes, sir.
Okay. Big introduction, but not really that. So, thanks for this opportunity and scope to talk about something from industry to all of you. It's my honor to be in Durham Sagar Technology and Management Institute. And just to begin with, I wanted to introduce something on my side. A lot of introduction already Madam have told, but apart from that, I'm in Bangalore almost from 17 years. So I belong to Bengal, West Bengal, but you can call me half Karnataka. Yeah? And I'm personally married, and my personal hobby is doing troubleshooting of gadget. So from my childhood, I used to damage any of the electronics gadget what we had at home. Second, almost 16 years of experience in industry. In automotive industry, specifically I joined Bosch. But before that, I started my career in industrial electronics and consumer electronics. Then I went to aerospace and defense electronics. And then again went back to consumer electronics, but I was not getting that gig. What is needed for an engineer to live their life. I was very passionate about cars from beginning. So when I get the chance in Bosch, it was a very honored situation for me to get into automotive industry. I joined Bosch in 2010, almost 13 years, I'm still in the same company and driving my business there. So my specialty is in the brake system engineering, basically electronic stability program, anti-lock brake system, automatic cruise control, electromechanical brakes, decoupled parking brakes, many products. In India, it's still growing up. In many of the recent cars, you see the ESP or ESC, but other than that, there are a lot of things in brake system which is actually in the global market. Slowly, we will experience that. Now, we talk about today's topic is role of digital transformation and industry 4.0 in product development. And when we start about this, my main agenda is to connect you with the technologies, what we have. Main focus will be that what are the different technologies we are leveraging in these different dimensions for product development. And your role, what will be your role in that case? You see what kind of opportunities are there in this kind of technologies, what you can actually transfer that to your students, and prepare for the industry. That should be the purpose, right? That's what we are made for. So let us start with the agenda, what we wanted to bring it today. We talk about the digital transformation, we talk about the digitization, and digital transformation. There are a lot of misconception about this word, and it's very buzzy word. It's very close, right? Digitization, digital transformation, and digitalization. But maybe all of you are aware, but I try to rephrase that. Then we talk about that, what are the digital transformation in the product development area. After all our explanation, we will see some videos, some case studies. It's important to, from industry side when I belong to, I always feel that when I try to connect one concept, one theoretical concept to a case study, it is much more easy for us to grasp and control, right? And this is what also I will try today. Tell you about some case study so that you can connect at what specific topic we have focused or digital transformation is focusing and what is going beyond that. Then we talk about Industry 4.0. We try to understand the different technologies. Again, I will try to bring a case study also from Bosch in Industry 4.0. There is a specific topic I also wanted to focus, if time permits, that is manufacturing analytics. That means what is that Industry 4.0 is doing for the manufacturing unit. What are the different factor of successful digital transformation, what we have to focus basically. And then we talk about the different lesson learned and best practices across the industry. And then I will also touch upon that how industry, Industry 4.0 is developed by which country?
Germany.
Sorry?
Germany.
Exactly. So Bosch is one of the pilot and leading for that. So when we have developed that, what it have done? What does that mean from factory point of view? That I will touch upon. So let us start digital transformation. And I want to make this discussion interactive. Otherwise, I will be only speaking and you will be listening. So try to make it interactive. Anybody of you have some idea on the digital transformation can just tell me what is it. Anyone? It can be wrong, no worries. It can be right, then appreciate it. Anyone? Madam? Any idea?
Designing the product.
Okay, good. Design the product. Anyone else? Add the words. No need to give a complete definition. Just add the words. This should be a game.
And digital aspect to any of the product.
Yeah, digital aspect. That's also very important. Design and digital aspect.
Involve more machines rather than humans.
Sorry?
Involve more machines.
Bingo. That's the topic. In general, if you talk about the industry, the digital transformation is a sophisticated system where we use multiple digital technologies. Yeah? To do what? What is the purpose actually for digital transformation? To reduce the effort, right? To enhance some efficiency, to gain some cost, right? This is the purpose of digital transformation. You were able to hear, right? Then I don't need this. So again, it's a industry-specific definition. So basically, it's a set of electronic tool and software by what we use to replace the manual processes and the simple spreadsheet, the Excel sheets basically. A lot of Excel sheets. In college institution, I know the amount of Excel sheets, and you can imagine that this is 3 times much bigger than industry. If I have to maintain that. I have joined Bosch in 2010. I told you. I was a very lucky person among many other lucky persons that to see this transformation. I have also started working with big schematics. We have a board, right? We have a marker. So schematics, partly many of you know the circuit design. So we used to open this big schematic in a board, in a table. 7 engineers are sitting for different modules. Somebody is a power supply module, somebody is communication module, somebody is a some input output, somebody is a microcontroller module, and everybody is looking at the big drawings and checking whether the circuit is correct or not. I have started Bosch in that, and now today what we have done, we will come back. So, and with this digital transformation, these are the main focus: that operational efficiency, customer need, revenue growth, and competitive advantage. Yes, of course. Operational efficiency means what? Almost globally, every big leader or president, vice president or the management side, they try to, that's the first point to attack. Yeah? The operational level task. Operation means what? The task what you do regularly, right? That's the operation. Like you are coming to institution and the first thing you do, you go and do your biometric. And then you start working, right? That's the operational level task. Some of the industry experts thought, do you really need to do this biometric? Trust me, this was there. Even in my previous companies, it was there. I had to also do that. But that process is changed. With that, how much we have get? Can you calculate that? You have to go, you have to stand in a queue, you have to do biometrics. Sometimes it is working, sometimes not working. Again, you have to press, you have to change the figure and many things, right? So with that, we are 40% executives basically believing that operational activities, if we can reduce or change to digital transformations, then we can bring a lot of benefits of it. Then the customer need. Yeah, customer need. What is that customer need? Anybody of you have XUV 700 Mahindra? Or experience that? What is the complexity of XUV 700 nowadays in India? It's a very, very buzzy device. You have to wait for 9 months. 9 months minimum. Yeah. So, do you really like to wait for 9 months after paying the down payment? No, right? You don't like it. So you wanted to get it much faster because you have decided you have some good muhurtam coming. Yeah, you wanted to break the car in home, do pujas and start driving. But Mahindra is not allowing that. So that's the things coming up. So Mahindra, what the boss is also trying to understand that the need is actually driving. But if you have a digitalized platform, example, if Mahindra can assume or forecast what demand will come in 2025 in month of February, by today, they will be ready to supply your car in 3 months, right? That is digital transformation. Forecasting, prescribing, these are the digital transformations. What to do, how to do, that will go low. Revenue growth. And this is very important person. When we talk about this effort, you go to the biometric and then come back, at least you need 10 to 15 minutes to do this activity. But for example, you have something in your tag. You come across the gate, it is automatically detected that you come in the tag. Yeah, there is a back chain is also possible, but digitalization is also capable to do stop the back chain, right? The back chains basically. 10 minutes for 30 people, if you are selling every day, 300 minutes. In industry world, if you calculate 1 hour is equal to $30, for example. In 5 hours, you are saving $250. It's big money. In a year, in a month, 2 months. So that's the revenue actually. It's operational level cost, which we can reduce and increase our revenue growth. Competitive advantage for sure. For example, what is that competitive advantage mean? Many of you have cars. Probably if you go for servicing, how do you prefer to do the servicing? How do you do? Madam, you have a car? How do you do the servicing? You call the service center and book your appointment? Right? But you know there is a platform also, right? Through online you can book it. Now, for example, you have a car from Tata who doesn't have this platform and you are staying 40 kilometers far away in a villa in Bangalore, outside of Bangalore, and you know the service center is in Bangalore. Do you really like to come and book and then find out that okay, you do not have the service facility available that day and you have to wait for 1 more week? No, right? You book it through online. That is the competitive advantage. Who is better? Who is able to give you the better scenario, better efficiency on services? That's the competitive advantage. Yeah? Now digitalization and digital transformation. This is the main 3 buzzwords. We'll try to understand the difference. But before that, any one of you can tell me what is the difference between change and transformation? Very good. Give me the example from English. No need to go for engineering and your study or syllabus. Anything? What is change? Sir? How do you define change?
So like digitalization of money.
Forget about digitalization. You tell me what is meant by change.
Now paying to the market, and now we have digitalization. Google Pay, GPay,
Hmm.
all these things are there and easy for transmission of money.
Correct. So, the change is something which we wanted to do today, but if it doesn't work, we wanted to go back to the previous one also, right? This is the change. And what is transformation? Any example you told about technology? Whether transformation can allow to come back to the previous? Any example? Physical example. Try to give something from your surroundings. We don't talk about the engineering. We don't talk about the syllabus today. You have seen Caterpillar? Caterpillar is getting into butterfly. How do you call it? That's transformation. Because that butterfly cannot come back to Caterpillar anymore. Correct?
Yeah.
But what is changed? You are paying through Google Pay today. You went to Kanapura Road and find one small shop to have some tea and find there is no Google Pay. What are you going to do? That's changed. Yeah? Now digitalization and digital transformation is also similar, but a little bit different. When we try to adopt or collect some data in a digital way, analog data transform into digital way, that is called digitization. Clear? For example, in our electronics, many of you have already studied ADC, analog to digital converter. Yeah, bits, resolution, complex, we will not go there. So digitization is what? You transfer the analog data to digital form. That's the digitization. Digitalization? Anything? How do you, when your exams, the students have given the exams and you have checked your mark sheet, and how do you inform from your authority or your management or your department that what is the score sheet of the people? You enter it in a form or in a platform, right? So, the way when you are changing the process from manual process to digital process, that is digitalization. So, you are already working on the digitalization, but we don't know. Many of us don't know that this is digitalization. Remember 10 years, 20 years back, when we did not have computer. Sir, you remember your old days, initially when you are joined, you have to make it and prepare and give it to your boss, right? That was the digital, that was the normal process. Now it is digitalization. What is then digital transformation? It is not a short-term action. It is not a particular process. It's complete strategy. We wanted to make Dhananand Sagar University and Technology Management completely digital transformation. What do you want to do? You cannot focus only on that particular activity. You have to aim first, vision. What I wanted to do? I wanted to bring efficiency on the students. I wanted to bring efficient methodology for the classes, trainings. I wanted to make efficient way of managing the exam and infrastructure. That is the vision. And for that, what are the different digitalization process you have to follow? That is called digital transformation. Yeah. We'll try to see that how actually industry is saying that. More or less same way as I explained. So this is converting analog data to digital format, turning analog process into digital ones is the digitalization, and reshaping organization by digital technology is digital transformation. We will know about the technologies. Yeah. So sample quantification, signal manipulations, yeah, storage, transmission. Somebody was supporting me to get the correct voice clarity, right? That is also digitalization, because you are trying to change the manipulation you are trying to do with voice and traveler voice, right? That is digitalization. See, examples are there everywhere. If you are right, you are there, you are back, in front, everywhere it is there, but just you have to correct. Efficiency improvement is focused on the digitalization as well as the business benefit. Information transmission, yeah, the same way. Today, I don't know, but I remember in my childhood days that my mom used to take me on every Saturday to market. It's my home, from my home to market was almost 1 kilometer. We just used to go by walk. For what? To make a call on my maternity uncle. Every week, Sunday. This is normal routine. Now we do that. No. What we do? Open mobile, WhatsApp, Instagram, many more. Yeah, just how are you? Everything is fine. Coming next day. Gone case. So, and digitalization was comprehensive strategy. That's what I'm telling. Digital transformation is not connected to a single source of benefit. It is complete benefit introducing the digitalized process. And this is always take driver and customer expectations are fulfilled. Yeah. For example, if my customer is expecting a component delivery for next 5 years with this amount, if this process cannot be digitalized, I cannot meet that. So that's what the customer centricity is always in focus. There are some similarities also with this. What are this? Everything is technical driven. Trade driven, productivity and efficiency is everybody's focus. Leveraging data is also everybody's focus. We are generating 100 number of data every day. You work, you see, you open your mobile and just set your daily working app. Then it will give you data that how much you work, when you have stopped, when you go right, when you go right. That's data, right? But this data will be also useful for others because you are showing a trend. Yeah? So there is a lot of usage of data. That's why digitalization and digital transformation, everything leveraging the data. But there is some differences also. What are the differences? The scope is different. Here I want to do small activity, just sampling, and maximum to maximum storage and transmission. Here my focus is to improve the efficiency. Here we wanted to make a complete transformation of the strategy, business strategy. Impact level and end goal is also different. Everybody has their different focus. Now we go to this digital transformation in product development. Yeah, very important things. Basically, this is what they should be. This is the take-based slide kind of things I can tell. So digital transformation in product development is not just a trend or a feature or just a super nice buzzword. Basically, it's a fundamental see that how we do business. How we do business. Let's take an example. Amazon. 10 years back, somebody had placed some order in Amazon. You remember something? It was you placed the order, and at the end of the day, after 3-4 days, or maybe forget about Amazon, any other online deliveries, there was no tracking possible, right? There was no tracking. I don't know who is coming. Even some similar situation also today in Blue Dart or some courier services. There is on the way, but you don't know that how to track it. But just remember that Amazon, every step, package is saved, now it is transported to different location, that comes to home hub, then it is out for delivery. Sometimes it is exhausting for us, but that is digital transformation, right? Because now you can see everything on a just button of a, just click on a button. Yeah. So the value of digital transformation for productivity, that is also a very important fact. What are the important facts? The first thing is that one single source of truth. Now imagine a industry who are actually building mobile. Simple example, not go for car and mobile. You need a electronics engineering team, you need a mechanical engineering team, you need a software engineering team, you need a quality, you need a marketing, you need sales, you need probably vice president. Now imagine, before you go into this slide, that all these guys having their own database of the product. Means mechanical engineering have opened a schematics or part list or a design document by his own. Engineering department, electronics engineering department, they have their own schematics and part list. Marketing have a different set of documents. And sales having a different set of documents, and your bosses, they have a completely different scenario. What is going to happen? Whether this product will be successful? No, right? What will happen? And just before the start of production, everybody understands, oh, there is a bug. Oh, sorry, I just forgot. There is a small notches on the mechanical market. I forgot to take it. That's why none of my cover will fit. Oh, sorry, there is something happened on the electronic side. I forgot to fix this bug. And that's why customer was asking to have a dew drop model, and I messed up with the backend camera also, right? So, for very important part to get a product development team synchronized, that everybody is using a single source of data. Now consider you have a SAP system. You have some understanding what is SAP system is all about. It's a database. It's a centralized database, but every department has their own access. Data is same, but the data, what you wanted to see, the electronics guys wanted to see the electronics level data. The mechanical people wants to see the mechanical level data. So the same product data they can see from different sources, but the source of the data is same. That's why it's called the single source of data. And that is definitely the advantage, right? You will be able to fix the multiple bugs and fixes much before the SOP. You don't have the last minute chaotic emails running here and there. Then we talk about the streamlining the communication. Yeah, that is very important, right? Now, for example, person on the this tube, you are trying to connect with your colleagues in industry through mobile call, yeah, and then another person is trying to do a chat, and the other person is trying to do Instagram, another person is trying to do another thing, maybe landline call. It's a chaotic situation. We have to streamline the communication. Communication is always the core of any successful project, product, operation. If we make the communication clear with each other, there will be no chaos between anybody. And that's what the value of digital transformation is also coming. Yeah? So all of boss entity across, just coming from industry example, we don't use WhatsApp and we don't use Instagram or mobile calls or anything for the operational purpose. We have our own system. Yeah? That's called MS Team. That is also, Microsoft Teams people are using also. So Microsoft Team is also channelized. That is authorized, approved by our head authorities, and this is the single source of communication for everyone. So you can make a call, you can make a chat, you can upload the files and everything in the same app. That's very, very sophisticated area. Then we talk about the simplifying the complexity. That's another part of the story. That's the value, basically. For example, when this rapid prototyping. Have you heard this word, rapid prototyping or 3D printing? I can tell you one of the examples which I recently faced. There is a OEM in Indian market. They have come up with some market quality issue recently, and I was formulating this topic, and they were giving up and down escalation to boss. What happened? Ants, ants, small red color, black color ants. They are going to electronics unit and damaging the whole electronics. What happened? You are driving and then one ant goes inside the electronic unit and suddenly the brake system failed. What will happen? You will make an accident, right? So it's a market quality issue. And that OEM was actually taking my class up and down till late evening, late night discussions, how to solve this problem. In current industry, starting from mobile phone, TV, or anything you think about, there is no ant-proof design. There is nothing. You cannot prevent ant to go. Literally after this escalation, I have to jump into biometric or biology research. What kind of ants are existing in the world? What kind of ants are existing in India? How the size? What is their size? What is their nature? In last 30 days, I made small research paper for ants. Jokes apart. So this is what the escalations. Now we have to make one counter proposal to prevent the ant entry in the electronics segment, right? It's a very important issue because that OEM was claiming because of your issues, my market share is going down. No one is interested to buy the car. Every day there are some calls from Gujarat, some remote area, from Bengal, some remote area, from Kerala, from Karnataka, remote area. Some cars are damaged because of this ant. The ants can be so chaotic you cannot imagine. Yeah? One ant is disturbing one issue, next minute my mobile is ringing. Yeah? This is that much of complexity. So to solve this problem, we have set up a task force. Yeah? You know the task forces are very, very dangerous thing. Yeah? In your days, don't try to be part of task force, my personal opinion. So task force is set up, and I was unfortunate leader of that task force, and I had to define some action for everybody that what they have to do basically. Yeah? So design team come up with a design how to prevent the ant in very next day. Yeah? In 7 hours they completed the design. The validation team completed the whole assessment in 3 days. Yeah? And now we have to validate our design and report to customer and say that we have a proposal to stop penetrating of the ants in our issues. For that, what we are going to do? We have made the design, we have a nice validation plan, we have a nice concept. Can you go like that to customer? No. Then you are losing that competitive advantage. We have to do minimum validation of our concept, right? The POC which you call proof of concept, that the kind of projects what we do in the college, similar kind of things. But how to do that? Because if it is a mechanical part or electrical part, you need a certain amount of time to design the sample, to get the sample from a supplier, right, or from your own house, right? What we have done, we went for rapid prototyping. How? We designed the part, we know it is a metal part of stainless steel, and we made a 3D printing of it. Yeah? We have done the 3D printing. Can you do the validation of endurance, magnetic, corrosion, such kind of things with 3D printing material? Anybody can answer? Not possible. Because 3D printing material is not equivalent to stainless steel, right? But we can do basic judgment, the fitment, the measurement, the manufacturability, the reliability, yeah? Adaptability, traceability, such things we can do. So out of 100 number of validation, at least 60% we are able to cover with the 3D printing. Next day, morning meeting set up with customer. We told, we have a plan, we have a validation done, this is our result. Tell me, you have to pay this much amount. Are you ready to do that? Do you think, what do you think? What will be the response from customer? They accepted the proposal. They apprised the boss and me that okay guys, super job. Whole night you have worked like that. They were very interested and very happy to see the design, but they declined the design because they are taking money. That's another story. But you understand what is meant by the simplifying the complexity. You don't have to wait for that much of time to get the samples from a supplier or from a mechanical sample shop. You just go for 3D printing. Yeah? You can also do it in your projects basically. The educational project, what you do, you can use it. It's a bit costly, but very effective. Now, digital transformation in product development, these are the different methodologies we use. What are the different things? Digital thread, model-based system engineering, simulation-driven and digital twin. Yeah? I will try to explain that story in a different way. As I told you, that you have, is it a panel marker? No, right? Okay, maybe I will try later. So first let us try to understand the digital thread. Any idea about digital thread? What part? We know what is thread, right? The thread is a kind of thing which is connected multiple people. Now, as I told you in the first example, that you have engineering, you have mechanical engineering, electrical engineering, computer science engineering, yeah, all of the different departments in here. Yeah? Now, your principal wanted to pass a very simple message in a very simple way, where all the departments get the news at the same time. How we are going to do? Maybe they will try to announce in public address system. But what happens if the computer science department public address system is kaput, means damaged? Then computer science guys will be sitting in the classroom, right? Electronics and mechanicals in the first floor. So to avoid that, what is that digital thread is created? Means a channel through which everybody is connected. SAP system. Yeah? You just put a message and send it. Groups, WhatsApp groups, digital thread. Yeah? So you understand how the digital thread working. Multiple different dimensions of industries, divisions, GBs, or departments are connected through a imaginary thread. You cannot see the thread, but it is an imaginary thread, how they are connected, and through that there is a smoothless information transmission in two ways. Both the way. You can receive the information, even you can pass the information. Sometimes it is a duplex, sometimes it is simplex, yeah, but that's the digital thread. Now, model-based system engineering means what? Yeah, what is that? Maybe you are also developing multiple projects, products in your college projects, but imagine, just imagine, one of the last time what you have seen a circuit diagram or mechanical guys, if you are there, then think about a mechanical drawings last time. You have some different block, right? Coming from the electronic side, you have a power supply block, you have a communication block, then you have some microcontroller block, system ASIC block. Yeah. For every project we do, we have to start from the scratch and get this circuit all together and get a nice schematic, nice drawing of the circuit diagram, right? Instead of that, you come back to a one level down and created models, power supply models. 3 different power supply design is possible. 1, 2, 3. Then you created communication model, CAN model, maybe flexi model, maybe lean model. Then you created 3 different models type of it. Then you have created a microcontroller. Yeah? It's a 8085 microcontroller or 8086 microcontroller, different microcontroller set. Then you have created a system ASIC. System ASIC 1, system ASIC 2, system ASIC 3. This is your database. Yeah? Now tomorrow, customer is coming and asking that, okay, I need a system wherein I need A microcontroller, B system ASIC, C power supply, and D communication channel. What you have to do? You have to take the circuits from the pool and just integrate. You don't have to do anything from the scratch. Correct? Because every models are quality available. Yeah? Next customer come, he needs B kind of microcontroller, D kind of system ASIC, A kind of CAN communication, and C kind of system ASIC. Then again you don't have to start from the scratch because your models are ready. What we have achieved with this kind of concept? One, efficiency. If you have to start a project from the scratch, you need 3 months of time to prepare this schematic. But if you have these models ready, you need 2 minutes of time and your schematics are done. Efficiency. Second, you have simplexed the problem again. The complex topics are again it down to the simple level. This is the model-based system engineering. There are a lot of advantages. The behavioral aspect, system architecture, requirement is also possible. How it is connected to industry? Mahindra Thor, Tata Harrier, XLM6 or Jimny, multiple different kinds of vehicle, right? Do you think Bosch is developing for every product from the scratch? Then we are gone out of the market. And Continental, Denso, they will take care of the complete projects. We are not doing that. We are developing this model-based engineering. We know that what kind of architecture is required for a vehicle. And we have set up smaller vehicle, sedan, bigger vehicle, SUV, more smaller vehicle, hatchback. For different vehicles, what kind of system architecture is required, what kind of electronics is required, what kind of force required, what kind of motors required, we have a database. Every time new projects come, we just take it up, tick, create it, deliver. That's called model-based engineering. Are you with me? Flow. Are you able to connect something in your head that how this model-based engineering is working? Yeah. Then we talk about the simulation-based design. You guys are also doing simulations for something, at least P-Spice and P-Spice. We're doing, right? Why we do that? Sir, can you tell why we do simulation? Or do we need it?
Yes.
Why?
To see the result.
To see the result. Anyway, once your product is ready, you can see the result, right?
But before set up in the hardware system, we can simulate and we can see the result.
Correct. Seeing result, what you are doing, that's the important part of digital transformation. Seeing the result is okay, even with the, but checking, huh? Correct, exactly. It is like a forecasting something. If I change this model from register value 1 kilo to 1.5 kilo, how it is going to impact the whole circuitry? The thresholds will change, the voltage will change, the ampere will change, current will change, everything will change.
Yes.
Now tomorrow, this is one advantage. Second advantage, there is a failure case reported of your circuit. If you have this data already, the failure cases data, you have already simulated this failure cases data. Somebody have reported, sir, from the last week you have told that okay, this is failure. So before analyzing the going back to the failure case, you will see that which of data is matching with that failure data and say this is the problem, right? This is what is called simulation-based design. Everything. Now, can you imagine till what level the simulation are used in the industry? Because we are doing a P-Spice or P-Spice simulation and all, right? There are multiple industry-based applications which are, because P-Spice and P-Spice are not recommended tool for the industry, but server simulation, ANSYS simulation, such other tools we use for that. But can you imagine what kind of, till what extent it can go? I will tell you one story. There was one of the OEM for Indian market, they wanted to launch a vehicle very fast in the market, very fast, because they have a very big competition, because other two OEMs are actually fighting to launch the vehicle. Maybe some of you know in last 1 year stories of vehicle launch in Indian market, you'll be able to connect that. And those guys have wanted to, they know only Bosch can do it. None of the other competitor is able to deliver the product in 3 months. For our typical ECU development brake system project, we need 2 years of time minimum. But we have to deliver that product in 3 months. What we have done? There is a very special activity. We call it winter testing. Yeah. What is that winter testing in the brake system? There is a lake in Sweden. It's a very remote area in Sweden as a lake. And this normally from November till April, this lake is frozen. You can also check it Google, winter testing of Bosch. This lake is frozen. 100 numbers of engineers travel there. It's very costly, very difficult to stay there. but still our guys are staying there. And then we drive the car in the snow field with multiple different maneuvers. What is maneuver? Different function. If I brake in panic situation, if there is a split, means for example, if you connect the split mu concept, you are driving a car or you are driving a two-wheeler, two wheels of your car is actually in the solid interface and two wheel of the car is basically in the muddy interface. Does the brake system will work at the same way as it is a concrete interface? No. You have to tune the car, you have to define the correct parameters in that situation. Car should be intelligent enough to identify that one of my leg is actually in the muddy phase, another of my leg is actually in the concrete phase. So such kind of complexity and winter testing, this kind of winter testing, it's a very costly element. Almost, if you consider a project of 1,700,000 or 700,000 euro is required for that winter testing. But for the 3 months of projects, what we have done, we built this vehicle model in laboratory. We created a virtual digital twin. We'll come into the digital twin. And then we feed the parameters. For a brake system, what are the parameters are necessary for a car? The mass of the vehicle. Yeah? That's very important. Center of gravity of the vehicle. Yeah? What is the different vehicle parameters like communication interface, like torque, yeah, such kind of things. We fit that in the vehicle model in simulation, and then we try to do the winterless testing. Yeah. Sorry, my guys are trying to reach me. So that is how we have done the whole winter testing in simulation, and then we launched that vehicle. So you understand the advantage. But can you keep the story as it is? No, right? Because somehow you have to match your simulation result with the actual performance of the vehicle. Then we traveled to New Zealand after 3 months. That was the New Zealand time for the winter testing. New Zealand is a different hemisphere, so the winter in Sweden, winter in New Zealand comes in a different part of the year, right? So we went there, we have done the testing, calibration, and matched the result of simulation and all. Through that, what we have done? We get some more data from real-time testing, and we fed the data now back again to the simulation model to make it more concrete. We analyzed and checked the result what you have delivered in the car. Is it okay? We find small differences, very small, which is not going to be safety critical. That means while driving, you will not face any critical accident. But we ask the OEMs, next time any of your person is coming to service center, please update the software. You experience that? The service center is updated. But don't tell me that Krishna told that. So this is how it is done. Yeah. So you understand how the simulation based things are okay. Now talking about the digital twin. Exactly, I get the same example. It was very difficult for us to launch the vehicle, but we have the technology, we have the competency, we know how to do it. We have super great simulation engineer across the world, not only in India, in Germany, in US, in Japan, China, Australia. We did the set of simulation engineers set across the world and find out the model, digital twin model of the same car. Yeah, it's that same car is coming in 5 doors next day, so don't have to tell the car name. But this is the way we have solved the problem. So this is the example of digital thread. As I told you, that multiple systems are connected here, and then we say the imaginary thread we talk about, and this is the model-based engineering. What I have give the example that you have different circuit modules, and whatever you need, you add it and deliver it, so that you don't have to start from the scratch. Then simulation-based design, as we talked about this, that okay, once you get that, so I told already predictive analysis, that's very important, and then the digital twin about the duplication of the car in the real-time scenario. Okay. So next, we would like to see one video. Basically, the things what I have explained, I will try to explain even through a video. It's not my video, but I hope we will learn.
Digital transformation. This video was created in collaboration with Lean Community. You can join the community and start using the Lean token. What is digital transformation?
video, stop that.
This video was created in collaboration with Lean Community. You can join the community and start using the Lean token. What is digital transformation? Well, let's start from what is not. It is not the digitization, the process of converting information into a digital format. So, what is the digital transformation? It's a wide transformation process that embraces the whole organization. This transformation engages all processes and employees, and it's built on a different strategic vision about how the organization itself should act and react with a radical shift in the mindset of the employees. Why do we say strategic vision and implementation? Because the mindset shift means to integrate all new technologies into all areas of the organization and the way we deliver our business. The change should impact the way they think our business, how we interact with our customers, how we manage our data, how we organize our production process, how we deliver our products, how we plan future business, and so on. But why companies should spend money and energy on this kind of radical transformation? First of all, to survive. Missing to keep up the pace with new technologies means that your organization could be easily blown away in a very short time. But without going into details with philosophy, a few good reasons are related with improving customer experience and services, being faster on the market, better understanding needs and situation, as well as being more effective in production area. Let's get now to some examples of real digital transformations from the most common and used to the newest applications. Marketing. From leaflets and newspapers to emails and mailing lists. From traditional shops to e-commerce. Loyalty cards and mobile apps. All these steps and intensive usage of technology have the only target to reduce unnecessary costs. Paper, wrong targeting, unsatisfied customers. And to improve effectiveness. Proposing only products that customers will likely buy, collecting data about customers' taste, anticipating trends and needs. What's up?
We brought you here today.
Providing services. A digital approach can improve the way we manage our data. Big data analytics is a process to gather precious but hidden information such as trends, patterns, or hidden correlations that could help us to make a better decision. Nowadays, basically, every app or software is using algorithms to understand customers' trends and prevent what we will need or buy in the future, or just to propose to us well that we will likely buy. To better understand what we are talking about, just think about smart home automation, where a simple device like your phone, connected with a kit of sensors and devices, can learn of your habits and propose you the right things at the right time. Devices can communicate with each other and be smart, creating what we call today IoT, the Internet of Things. In a production company, data analytics software can help connect all production machines, providing real-time data with useful info, not only about KPI telling us how production is going. Smartwatches and tablets used to support operators with checklists or improving instruction based on a specific trigger, a step in task, a specific time situation. Proactive maintenance, sensors, and data aggregation will help to understand when a machine is getting near a breakdown before it happens, or simply tell us the best moment to substitute a component based on a big amount of data and some small deviations that a human could never detect. Imagine data analysis of a vibration or temperature changes. And what about new devices that we know mainly smaller area and for the easier task. They are way easier to program and can support activities and tasks even for simple operations, of course with a limited investment compared to the huge robots we were used to. It would be impossible to list all potential benefits and technologies that could be listed under the digital transformation definition. But it should at least be clear that digital does not mean simply switching from paper to a PC, but it's something deeper. All examples you just saw are related to a different way of seeing things. They are the results of a hard change in the way we were thinking of doing things. It is the output of a strategy that set up a clear goal for a new or enlarged business, a big investment, a change of direction, and of course, a cultural change in the employees of our organizations. A simple digitization of our company will not require for sure any special skill or investment. But transforming our business into something different, using new and different tools, is something that needs to be planned in advance with a special focus on the knowledge and skills of our people. New technologies will require additional skills, or the risk of wasting a big amount of money will be real. For example, if a few years ago, hiring a maintenance operator was pretty easy, considering just his or her technical, mechanical, or electrical skills, today we will need to plan to get on board people with digital skills, robotics, programming and coding, PLC and connectivity, all topics that were unknown a few years ago. We need to even think about topics that today are just remote concepts or prototypes, but that maybe in a few years will be a daily and natural thing. It was of course not planned and not a pleasant event for sure, but the COVID emergency pushed most of our organization to deal with a new way of making business. As we said at the beginning, expectations of a digital transformation are related to improving efficiency, being faster to the market, increasing customer satisfaction, and thus gaining more business. Like in the lean approach and continuous improvement, a digital transformation is not just a matter of improving, but is something you need to plan as a long-term vision in order to survive and gain advantages via your competitors. Missing this change will put an organization in a risky condition of not surviving the next big technological wave. Thank you for watching the video. Remember to like and subscribe.
I hope you like that video. You have some fair idea now. Just to add that, and we'll finish this digital transformation topic and go to Industry 4.0. Employee satisfaction is a very big concept for the organization, right? Employee satisfaction, right? Student satisfaction in the college, employee satisfaction in the industry. If employee is not satisfied, what will happen? Attrition. People will join, leave in 2 months. And sometimes what we are working from the boss or organization point of view also, that employee satisfaction doesn't connect directly to the monetary benefits only. The circumstances benefits are also important. So as you have seen that the main topic is that we should have a vision before we go for the digital transformation. And we have defined a vision sometimes back that we wanted to increase the employee satisfaction to the next level. For that we are targeted 2 or 3 things. One is that whenever employee comes in the organization, we will try to read their face expression. Based on that, we decide that how to bring or discuss some topics that it's a facial expression. So every boss employee goes into the campus, there is a facial expression, and through that we will try to read what is the facial expression on that day. Is it good? Is it not good? Is it a bad mood? I do not want to bring some additional expression topic to him. Yeah, this gives a lot of opportunity for the managers to take the people in the right way. Second thing is, there is a lot of problem also for this AC ventilation. At least in organization we have faced this. Sometimes AC goes up, sometimes AC goes low. Every people have their different level of capabilities or different level of tolerance. Everybody doesn't look high speed or AC at all. So boss also developed this smart campus in RWD where people are sitting in one place, people are sitting. The AC is equipped with machine learning. The AC will try to read that particular person culture, person attitude or behavior, and based on that the AC waves will be operating automatically. Nobody has to call the customer service center and say that my AC is not working, please fix it, it is too cold, it is too hot, it will be done automatically. That level of digital transformation we are going to do. Okay, next. case study. You know about the Tesla, the electric vehicles. Yeah? So they are one of the biggest examples of the digital transformation. They build a lot of electric vehicles, energy efficiency solution, and also renewable energy product. So what was the challenge? The challenge, you see, they have told that they wanted to revolutionize the content market of auto industry through electric vehicles. But you know, before Tesla get into the electrical vehicles, nobody in the world was ready to accept that electric vehicles can be a future or can be realized one day. So up and down, people were, it was like a sarcastic situation for them. But that was not a disappointed point for Tesla. Yeah? So Tesla have defined a strategy. The strategy was focus on utilizing the number of emerging technologies. And they define a path, that's also next part. They wanted to focus on innovation and sustainability. They developed cutting-edge electronics technology vehicles, and then they wanted to come up with autonomous vehicle to enhance operational efficiency. So they defined a very nice roadmap. Through that, they come up with two super nice digital transformation examples. One is this over-the-air software. Still, for India, we have to go to service center to get the software updated, right? What happened if that OEM or your car manufacturer is able to update the car software without visiting the service center? You connect your car in a network-based or internet through mobile or through Wi-Fi, and the software gets automatically updated. What you are going to decrease there? Your effort to go there, your effort to have one person dedicated in service center to do the software update. Through that, they gain a lot of revenues. Almost 98 million euro they saving. So that's what the over-the-air was one of the biggest digital transformation, and they were the pilot. Now multiple companies are actually using it. Mobiles, you know, this is there, right? Google Apps, update, blah blah blah, things are coming. But in car also, this is possible now. Second topic is the autopilot. Morning I was talking about this autopilot topic with sir. So autopilot is also that in highway, German autobahn, German roads are world famous. You can drive the cars in unlimited speed. Personally, I don't drive more than 70-80 kilometers in Bangalore, free though, not enough. But there also I was able to drive in 150-180 kilometers. It's not a speed at all, it's very simple. But it's a very long stage road. You will feel bored to drive in that same speed, in the same way. Yeah? So what happened, because Germans are also a little bit lazy on this kind of things, they also wanted to have that, okay, somebody at the time of car driving, they wanted to do something else also, that something productive, maybe having a coffee or reading a newspaper. So that autopilot feature they have implemented, this is also digitalized. Multiple systems are connected in the car. They are reading the sensor data and detecting whether speed, what speed to be maintained. Is there any vehicle in front of me? Is somebody showing from the way? And based on that, they are limiting the car speed. That's called autopilot. This is also a recognized product systems which we have brought in the automotive industry. Yeah? There are different approaches on this. So important part is that we focus on a data-driven future. We collect the data from the different vehicles data, and then collect the data through sensor, through embedded software. We process the data, and then we try to utilize the data. For example, through this data for multiple vehicles, you can actually read the driving pattern of a person. Maybe madam, the way she is driving in Bangalore road, maybe I'm not. But we are both paying the same insurance cost, right? She's very stable and driving very safe. She doesn't have to pay that much. But I'm a very rough driver. I'm going here and there. I have to pay too much. But imagine if there is a system which can actually, based on your driver pattern, can decide your insurance premium. That would be much fun, right? Nowadays you are getting a lot of calls. Means, I know my insurance is getting expired in 29th February. Every day 30-40 calls. Please update, please update, please update. Yeah? Such situations we can avoid. That's also part of efficiency. And over the year approach, as you told, there are multiple benefits. One, that person doesn't need to be seated in the service. Additionally, you can reduce the travel time of you. Third, you are actually going to reduce the carbon emission. You are driving from here to Sailport to service your Renault, 30 kilometers, lot of carbons. That also you can reduce. So you need to identify the topics and then you have to connect the benefit of them. Now we come to Industry 4.0. Digital transformation is clear. At least I hope I was able to take you through some journey on the digital transformation. Yeah? Now we talk about the Industry 4.0. It's basically interconnected. But when we do the digital transformation in the manufacturing plant, Industry 4.0, it is typically connected to the manufacturing plant. How smart we are to produce product. Yeah, that's called the Industry 4.0. And this is also in sometimes we call this as a smart factory. Yeah. But Industry 4.0 is like a Robo 2.0. Somebody has to know what was Robo 1.0, right? So that was the first thing I wanted to bring in. This was in 1784, almost in decades before, when we tried to bring the heat energy and water energy to produce some product. Yeah, the energy, transmission of energy from one form to another form. That was the first Industry 1.0. This time there was nobody was able to produce mass. Maybe one product, maybe two products. Maybe today one product, throughout 1 year the product manufacturing done. Next year another product will come. That was the Industry 1.0. In 1870, we brought the electrical energy. Apart from heat and water energy, we brought the electrical energy. And we start doing this mass production. Yeah, now companies are ready to produce 100, 200, 300, 400 vehicles or maybe parts per day. That was the Industry 2.0. Industry 3.0, there are many multiple processes in the production. Out of that, we wanted to digitalize or automate some of the process. Not digitalize, but automate some of the process. Yeah, one process is connected to another process. And IT system, robotics are also built into that. That was basically done in 1969, just after the World War, because that was the time where the Industry 3.0 was in high demand across world. And then today we are talking about Industry 4.0. What is that? The interconnected system. Means you don't need a human person to be located in the lab to say that this machine is failed and I cannot pass the parts to the next machine. Yeah, it is a flow, right? The systems are interconnected. Even there is no person standing on the queue, but the next system is able to understand there is a problem in the previous system, and then it takes the control of it. Once it is rectified, the system 2 will start operating automatically. System 1 will start operating automatically. So it's an interconnected system. That is today's journey. There are multiple benefits we are getting out of this interconnected system, interconnected devices and all. For example, this is basically connected with IoT. We know what is IoT? Internet of Things. Give one example. Anybody. If you have one example, forget about company factory from your real life. I don't understand so technical topics. Give me something from your personal experience.
Sensors in class.
Watches. Smart watches. Very good. What do we do with this? Hardware. What else additional feature is there? Are you using that? What is that feature?
Steps.
Anything else?
Blending, walking.
Heartbeat, temperature. It is. Do you think that still it is considered as a Industry 4.0? Is it? No. Still now we are not using the complete feature of it. When this will be called as Industry 4.0? Once after reading your body temperature or heart rate, when the smartwatch is able to give a call to 40s, Apollo, Columbia, then yeah. Now we are talking about Industry 4.0. Future is coming, Industry 5.0. This is a pre-information video. So Industry 4.0 is talking about the IoT, machine learning, but still you need some human interference. But Industry 5.0 is basically cyber-physical development. Cyber-physical. You know, you have a completely connected system on the cloud. There are some bad examples, good examples also. Who have seen Matrix? Everybody probably. Matrix movie. You remember what happened? Can you tell one or two lines of it?
He'll ask the hero to choose between red pill and the blue pill.
He went into the program and damaged everything. That's the cyber security. We need to protect our system. Huh? Otherwise, what will happen? You are trying to protect the Apple iPhone and you get the result as a Chinese iPhone. Yeah, that is not a good idea, right? So to protect our manufacturing unit, we need to be cyber secure also. That's the Industry 5.0. Yeah. What are the typical part of this Industry 4.0? What is there in the industry? So I just draw a small factory. Doesn't look good, but at least I can do it. There are multiple methodologies what is used in this Industry 4.0. What are these? This is Internet of Things, the sensor-based devices. Second thing is that what else necessary? The cloud computing. You are getting lot of data. Somebody has to process it, right? If you do not process the data, what is the meaning? So that's the cloud computing and analysis. Then we talk about after reading this analysis data, how you enable your artificial intelligence. Yeah, you must have iPhones. Somebody of you have iPhones, or somebody you have Google, Alexa also at home. You say switch off. Then Alexa is also switching on your AC tube lights and all. How? This is the process: analyzing the data, reading the voice command, and trying to do what a human can do. That is what is artificial intelligence. Now, if one Alexa can switch on your TV, radio, AC, refrigerator, everything at home, think about 100 number of Alexa in a production plant, what they can do if they are connected. Alexa 1 is speaking to Alexa 2, please stop the system. Yeah? So this is how the artificial intelligence and cobot we read about in the last minute, when humans and robots are working together. Why we are doing it? We are trying to teach the train. But would you like, madam, sir, would you like to train the robots? Then they will take our place. Na? Tomorrow we don't need professors in the colleges, no need of engineer, program managers, some robots will do. Yeah? No. You need professors, teachers, engineers everywhere. But machine learning is all that the robots are trying to read you, trying to understand how you do a specific activity, a particular way of doing, and they learn and they implement it better. So that's the machine learning. These are the most important methodologies used in the industry 4.0. But how we do it? How we do it? The first thing is advanced sensor. What does it mean by advanced sensor? Already said and told. What was that advanced sensor you have? He can read the iPhone can read the correct. So he is able to read the data. At the same time, he is also able to transmit the data, right? So this is how also the advanced sensor works. He is reading. This is what every advanced sensor has an IP, and this IP data they are reading and transferring the data to cloud. That's the advanced sensor. But you get the data in cloud. What do you do after that? You need to do analyze, computing, calculations, everything, right? To do that, what do you need? Embedded software. Yeah. So you have sensor, you have embedded software, everything is there. There is a lot of data. There is a calculation also. So with these two, what you achieve? Data collections. Your analysis is done. You have a pattern. You know that out of 100 people in your manufacturing plant, 90 people are super efficient. They are coming and doing their job. 10 people are the smart guys coming and having some tea, some smoke break here and there and wasting time. That pattern the system can get. Yeah, then you can take the necessary action. To do the necessary action, what you need?
Feature extraction.
Sorry?
Feature extraction. You have to extract features.
Correct, but you need somebody to support you to that, right? Who is going to support you? Yeah, that's the robot. And they are going to support you for the decision making. This is how Industry 4.0 is formed. That's the complete chain. Clear? We can do Industry 4.0 at our home also. Maybe many work for harvesting. You have it at home, right? Maybe space collection. Can you do it? Just think about it. That could be also a good project. So, through Industry 4.0, what we are trying to do? We are trying to gain the higher values, right? Everybody wants to reach to the top. What are the things we are going to do it? We are trying to get the production data. On top of that, we are trying to get the operational data or ERP. ERP is nothing but enterprise resource planning. For a manufacturing unit, it is necessary to know how much. Okay, I will not tell you. Tell me. For a manufacturing unit, what is if you wanted to establish a manufacturing unit of anything, you forget. What are the things you wanted to know first before establishing? Sorry. Sorry? Design. Design for? You will decide a product first. Then? You are not going to create a correct raw material, you are definitely. But, okay, now you go and buy a raw material. For example, when you build automated way of cooking biryani. cloud kitchen, biryani, and you order 500 grams or 5 kgs of chicken, mutton, egg, vegetables, 5 kgs of rice, everything you order, and you start preparing. Is that the right way of doing? No. What is missing? Sorry? Planning for what? Correct, exactly, we know. So the first thing is that you have to know the demand. Yeah? So somebody is working to create a demand. Then I know that how much product I have to build. To build this product, what kind of raw material I have to build. To build this product and to buy this product, how many human resources are required? You cannot prepare 5 kgs of you need 5 more colleagues to do that. And you cannot go to market and buy the products. You need some support guys also. So that is this all systems. When it is done in a big manufacturing unit, this system is called enterprise resource planning. You give the demand, the system will break down the topics and tell you these things you have to do this. That is what is called enterprise resource planning. Then we come to the supply chain data. Supply chain data means you prepare the biryani. Now what? You have to, you make a dunzo, right? Courier cost, or maybe Swiggy Genie, something you needed, right? So the supply chain data. And then, what is that? Feedback. Is it good or bad? For biryani, it will be always good. Yeah, so but you understand, right? This is how the chains are connected with each other. This is how, until we are able to complete the chain, that okay, I made this with this data, then this way I prepare this way I supply, this way customer receive. Now customer is not anything, some boring customer like me. Then you are gone case. You don't know whether it is good or bad. You have to change some spice level. Yeah, that's what the this is how you create the R values. We talked about the IoT. We'll go a little bit fast on this. Cloud computing. Also, we talk about that you can actually do the calculations and all everything very fast. It's very simple to understand like a cloud kitchen. What is the cloud kitchen? You have to set up. You don't have to set up a physical environment to support the customers, right? You can do it through a cloud. Same way, very lot of data coming out from the production. 100 number of companies. If you go to Italy, you can understand that. So many companies are there. They are creating millions of GBs data, right? But does it make, you need lot of space to save the data. You remember the older day, Amazon server, Boss web services and all. And lot of data houses at home. Even in your distribution probably you have multiple server data which is there. But instead of that, if you buy a cloud service from AWS, Azure web service, their target of their business model is, they will not do anything. They will just provide the space. That's what is the cloud computing is all about. Then AI event. So you read the data through IoT, you do the computations, through cloud computing, and then you try to analyze the data first to train a robot that how they have to do. The robot will understand for each behavior what action to be taken, and then the machine learning. Edge computing and cloud computing. Very small change, but edge computing is much more complex. The reason is when we try to analyze or calculate some data at the real time, at the same time. You cannot have the latency between the data to calculate from start to end. Because once you try to transfer the data from one place to one place, you need some latency, right? There's a jitter. If for example, many of you are already working on high-end primers in the microcontroller, right? HAT or GPU. So you know that you are connecting two signals in HAT. But one signal is coming through some big capacitor loop, RF emissions capacitor, and one signal is coming through a simple capacitor formula. So there will be always a latency between these two data. The way we receive the data, the way we process the data. In edge computing, some critical application, you cannot have that latency. For example, this is also visible. In hospitals and all, you see the patients, they have this button, right, to call the nurse immediately. If there is a latency there, what will happen? God case. What is hospital will go out. Yeah. So this is how, and then we talk about this cyber security. That when you are having multiple devices connected to your system, you have to secure that system also. Yeah. Otherwise, instead of Apple iPhone, you get Chinese iPhone. Remember that. And these are much more complex. Yeah, when we are breaking this over the air in the car is driving in autobahn, and somebody had the car and damaged it. This is also there is a more. This is something you can see in Hollywood just to experience. And then the digital twin. This topic we have already talked about. That every time you need a fast result to simulate something, to get the result much faster, to be predictive analysis, descriptive analytics, you need this digital twin concept. Yeah. Now we will again see, I think it's a very small video. What is digital transformation? Industry 4.0 work. Okay, I think if we have the time, we will go to this video later. It's a little bit bigger, but we'll try to check the case study first, of course.
In the environment of a network world, the fourth industrial revolution will bring about intelligent factories where men, materials, and machines are interconnected within the Internet of Things. The fusion of real and virtual worlds of production will bring about a highly individualized, agile, and resource-optimized mass production, bringing manufacturing closer to consumers. Session-5 was established in 1956 as a manufacturer of textile motors and pumps for the agricultural sector. It was since grown to become the largest manufacturer of agricultural pumps in the country with a turnover of 800 crore Indian rupees. With a 2,000-strong workforce spread over 5 lakh square feet of production space, we produce over 400,000 pumps annually. In our business, our greatest challenge was to improve our forecasting accuracy. We also realized we had to ensure better delivery commitments by ensuring that our manufacturing systems were both flexible and agile, leading to the right product being available at the right locations at any given point in time. It's not a classic industry prepares our vision. To realize this vision, we started out by implementing a smart manufacturing solution. The three units of manufacturing, man, machine, and materials are interconnected by using customized, specific adapters, and automated modules. The entire material flow in the factory was automated and well-regulated by the solution. Seamless integration of different
what we talked about. And boss is also working as a consultancy firm, so that means we take over the multiple projects from the market, specifically from the manufacturing unit. They approach us to transform their factory to smart factory, industry 4.0, and then we take it over and consult with what to do and how to do. Now coming back to this topic again on our agenda. I think last year, last 2 years back, I had submitted a patent on this, connecting the digitalization, digital transformation and industry 4.0 in the product development. That is what I wanted to do. Remember I talked about this meter testing in Sweden? And so much of complex, lot of people have to travel there, and lot of money. So my patent was actually to reduce this cost. How? Example that for every company there are 4 people are going. Instead of that, you send only one person who knows driving, nothing else. He is not application engineer, blah blah blah. He has basic understanding of driving. And you set up. Have you any time have seen or experienced or tried the VR consoles? In the watch it is there. You wear something and then you see that. And also some PlayStation. Have you experienced the PlayStation at home? You drive the car. Now my idea was, so normally PlayStation what you do? You try to give the inputs from your side, right? The kids are giving the inputs from their side and try to navigate the virtual environment. My idea was, we collect the data from the car, the person, only one person will be driving the car in the trace track. We get all the data in cloud computing, we analyze the data, and we transfer this virtual model to a secondary driving unit, a simulation model, something like a PlayStation, where a secondary person can see, maybe a vice president, maybe customer, maybe your colleague can see in that and experience as secondary driving. The driving is actually happening 7,000 kilometers far away, but you are experiencing. When it's taking time, you are experiencing that. With that, what you are going to get benefit? Huge cost reduction. Huge cost reduction. Because the staying on that very cold conditions is very complex. And then also, a lot of people have to gather, right? Because when we are trying to do the demonstration of a new product over here, the president, vice president of the big companies also they have to travel. They can save time. Additionally, so 2 things, cost advantage, save time. Third, you can actually give a physical experience to your colleagues who cannot travel to Sweden. Everybody cannot travel, right? Because of health conditions, blah, blah, blah. But if you bring it in your continent office, anybody can go and see it and experience that somebody else is driving. That was the application of my patent for this, still on the assessment and the authority level. But imagine similar kind of concept if you try to do it in your home. Much better, no? How the kids are driving on the road as a cycle and all. So this is how. Now we will go to this manufacturing analysis. We will go quick through of this. What is manufacturing analysis? There are different kind of things in the manufacturing unit. One is the people, then you have processes, and then you have the technology. The combination of all these 3 together is the digital transformation. Then only you will get the benefit. Now, in a manufacturing unit, they are getting a lot of data through quality data, purchasing data, supply chain data, multiple data, production data, downtime data, efficiency data. And you need something to do with this data, right? What you are going to do basically with this data? You will try to do this kind of things. One is descriptive analysis. What and why happened? For whom this data is necessary? For your boss. Means if I am a manufacturing unit specialized, then I need to submit this data to my boss. Every day after 5 o'clock, my boss is calling and telling me what is that happening now, what is that happening. I'm exhausted. I told my boss, no, I'm sending you a very nice link. You open that this data and see the data what is want. Yeah, that is what is called that when you wanted to summarize the result for your parts. That is the descriptive data. Second thing is that predictive analysis. Yeah, you will try to read the pattern that when somebody is getting ill, when somebody is getting little bit idle, when the system is going down. Through that, you will create the predictive data. Additionally to this predictive data, what you can do, you can educate the hypothesis and also you can implement the prevention method for that issues, right? That is called predictive, and this is prescriptive. This is also the same thing that you are trying to read the data through what should we do. You have a problem. Yeah, your your line is not capable to deliver 100 cars every day, what you are going to do? So for that, this prescribing data will be helpful. So these three kind of data analysis we do manufacturing analytics. There are two types of industry basically, industrial manufacturing. One is the discrete manufacturing, another is the process manufacturing. Discrete manufacturing is basically once you get the part, small part, and then you try to assemble it together for the same. So automotive, aerospace, electronics, appliances, furniture industries, everything is related to the discrete manufacturing. Process manufacturing is the chemical industries, petroleum, those food processing units, these are the process manufacturing. But common thing is that everybody is working with some data. They need the data. Yeah, as I told you, what is the need of this manufacturing analysis? This is the example or real-time application of Industry 4.0. Yeah, that's the called manufacturing analysis. So production volume, production cost, on-time delivery, first time right, and then also the revenue per employee. Such kind of data is very important for the big level of management. To commit something to customer, to take some action, to plan, to strategically plan the hiring resources. Such things will be only possible through this data. And through manufacturing analysis, there are a lot of revenues also customers are getting, because sometimes we waste a lot of money just for doing nothing. Yeah. But revenues can be increased also through this manufacturing analysis. This is also a BOSS development. And yeah, with this reason for increasing demand is coming from where? Because of, we know, car is demanding everybody. People are going out of Bangalore, two-wheeler is difficult, so need car. Yeah, that's one of the things. Then improve decision making. So we need to also improve the decision making. Sometimes we hesitate to take a decision because we do not have data. We ask, what happened to this? Can you call me and tell me what is happening? Next person is also calling and telling that, okay, tell me what happened to this time. We are lacking with the data. That's why we are trying to attempt to get the data to take the decision. Do I have to have 5 more people? Or is it necessary that I cut 5 people from the operation? So such decisions are critical. For the critical data analysis, you need to do the decision making. Enhance quality control for sure. BOSS is known for quality. Everywhere you go, there is quality is in focus. We cannot compromise or negotiate anything with quality. We delay the product delivery 2 days, but we ensure the quality. But that's what the quality enhancement data is also possible through manufacturing analysis. Competitive advantage we talked about. That's what this is all about. Yeah? Now, to apply this manufacturing analytics, you need to. There are 4 different steps. One we talk about the connect, collect, consume, and cognitive. Yeah, you connect multiple devices together. Yeah, get the data. Then you start collecting the data. Then you consume means you try to process the data, and then upon that you take some decision. This is all about Industry 4.0. These are basically how we apply the manufacturing analytics. This is applicable for anything. Don't consider only as a manufacturing at a big plant. Even if you are trying to manufacture anything at the home, that is also part of this. That you need a instrument or machine, you need a human machine interface. Then you need a SCADA. This is, many of you know, PLC SCADA, supervisory control and data acquisition system. Then you have this MES, production data, and then business application. All these 3 together can give a super strong Industry 4.0 setup for the manufacturing analysis. Yeah, this is a kind of a typical architecture. It's very complex, but I thought that you can spend some time, just have some loop. But this is the way. It's an architect. So when we get this project from a particular customer, that okay, we need to change this industry, the manufacturing unit to smart factory, then we try to read the context of the business, right? Then we have to define an architect. Because working level, what sensor is necessary, how to collect the data, where I am going to store the data, that is different. Before that, the architect level should come. That okay, how I am going to do that Industry 4.0 implementation in this. And this is how connect, collect, consume, and cognitive. These are the multiple things: CRM, customer relationship management, social media, IoT, cloud data. Then we go through the data integration, real-time data, landing zone, BOSS source, streaming data, for video. Sometimes you are seeing these new terms. Podcast, podcast. This is all connected to the Industry 4.0. This is the typical KPIs of manufacturing analysis. Means, what is my final aim to do the manufacturing analysis. This is my aim. I wanted to know order rate. I wanted to know first yield. How many products are getting passed on the quality at the first attempt. I wanted to know the deployment efficiency or overall equipment effectiveness. I have 100 number of lines. Every day I have to visit plant to check if all the 100 lines are on or not, right? But if I have a digitalized platform to know, to get this data, then it's easy. Lead time, how much time is necessary to produce the data or get the data? Are we making on-time delivery? Then this is the capacity utilization, your 100 people are, all the 100 people are working or not, that data also you can do, and the throughput. So this is the typical dashboard. Now, this will keep it. After a lot of digital transformation case studies, this is basically our lesson learned. From the beginning, I'm telling you, while doing a digital transformation or Industry 4.0 implementation, you need to have a vision. Without vision, it is not possible. It is not that action what you wanted to do, it is the vision what you wanted to do. Then, after getting the vision, you have to define a roadmap. That okay, you cannot do a digital transformation or Industry 4.0 implementation in 6 months or 1 year. Yeah, you need to define a roadmap that okay, by this year end, I will try to do 2 of these activity completed. Rest of the 2 activities will take in the next year. Then we talk about that core team. When we talk about the core team, it is not anymore a solo game field. Every engineer, every department, every person in the organization have to work together. That's what is called the core team, the connection. Finally, the customer centricity. We need to check whether with our approach, customer is happy or not. And all these things has to have a attention to continuous improvement. The way you are trying to define the vision, next year the market is changed. You cannot keep the same vision. Yeah? You have to do the continuous improvement also in your vision. You remember the story of Nikon, Canon, yeah? HMT, Nokia. I think then you are aware already what I'm talking about. Yeah? This is the last slide for me. I wanted to show you the when we have brought this Industry 4.0 in Bosch, the pilot projects, what we have done. And you will be surprised to see many of your activities, what you are doing in your daily day, is actually digitalized.
digital factory ensures the utilization of future-oriented technologies. will record potential error sources. Relevant video sequences are intelligently edited and subsequently analyzed. Recurring interferences are linked to known error patterns. Recommendations for action are derived from these patterns, and a group of personnel on site to act as skilled problem solvers. Industry 4.0 also represents flexibility for our employees. Mobile shift scheduling allows a quick and customizable shift organization. In our cafeteria, we experience the advantages of digitization on a daily basis. RFID technology improves the banking process and caters for a relaxing lunch break. Our success is based on the exemplary collaboration within our network of experts. In all of this, we pursue one clear objective: ensuring the future of our plant and thereby the future of our employees. Because there are some things you simply cannot digitize.
So the interesting part for me basically when I was there a couple of times in Blyser, rest of the technology was very well known for me. Blyser is in the northern part of Germany, which means many of the times it was slowly covered with snow. But I was very surprised to see that I don't have to pay the food by my pocket or something. Yeah? It's not even digital money. The system is so concrete. Looking at that food on that particular plate and that tray, the system is easily calculating that how much you have to pay, because every food is a different cost. Some €1, something €2 now, and it is getting deducted directly from your account. Amazing technology. And boss is getting up. Thank you very much. So that's all from my side today. I'm open to have answer any questions if you have any. I'm sure that I have fully contributed today. After this session, do not get exhausted. Try to connect the topics what I have told to your real life, then you will be fun. Thank you very much.
On behalf of organizing committee, we wish to thank our guest and the speaker for the session. I think you would have experienced virtual experience without any virtual reality, what Industry 4.0 and 5.0 is, because of the presentation. We hope we will remember all these things whenever we do drive any vehicles on road, especially your bikes and cars. Nothing is on the road without Bosch. So, yes. So, as a token of appreciation and thanks, I request Professor Rashmi ma'am to give a token of appreciation to our guests.